another technical, very interesting lecture coming up. Game development behind the scenes, yes. So we have the expert consultant lecturer at Mogo Media, teaching programming and game development. Software engineer, and he's actually a veteran in software field. 20 years experience in engine programming. Yep, it's we are into a niche market. I think it's not very common. We have an expert person like this. Expertise in PC, Mac, Linux variants, web and cloud platforms with a background in building scalable, fully scalable solutions. Mr Thomas Kuriakose. Yes, please welcome. Thank you.
Thank you. Yeah. Good afternoon, everyone. Can you all hear me? I'm not going to use the microphone. It's a lot more comfortable this way. But if you cannot hear me, please ask me to stop or repeat. Okay? So my name is Thomas Kuriakose. I'm from Mogo. Right? Mogo Media Academy is an offshoot from Jarana TV. Right? And we are a premier institute focusing on new age media and interactive entertainment. You can't hear me? The recording. It's a little uncomfortable holding this. Okay, I'll try, but I'm going to forget. To hold on to this. Actually, I'm going to put this down. Yeah. So I'm going to talk about computer game development. I'm assuming that some of you are interested in this topic, right? And you might have questions, right? I teach at Mogo Media Academy, right? I'm a software engineer. I teach computer game development, right? The technology side of things. What I'm going to talk about now is how games are made. Okay? Do you guys have any idea of how computer games are made? All the different things that go into it? Anybody? What are your favorite computer games? Fortnite? PUBG? Which one? I can't hear you. But okay, anyways, I'll talk about things. So, game development, what goes into it? Right? There's a whole bunch of stuff. I'm just going to loosely talk about everything. Right? But at any point, if you want me to specifically address something, please ask. Okay? Okay. Alright, so these are some of the things that go into game development. Let's say somebody wants to make a game. Right? How do they go about it? First of all, you need to have a game design. Right? Once somebody has a game design, they don't immediately go and develop the game. Like for instance, I might have an idea for a game, any game. I might not know how to make it. I might not know how to make the art, do the programming, do the animation. I might not know any of that. But I can create the rules of the game. For instance, you all know chess. Right? Chess has a bunch of simple rules. Right? All the pawns and the moving pieces, they all have simple rules. Right? But how should they look like? How should each thing look like? Somebody else might decide. Right? Now chess is a simple game. But if you take something else like Fortnite, or StarCraft, or Age of Empires, or Halo, or Call of Duty, somebody might have an idea for a game. But you need a whole bunch of people to come in and create the environments, the art assets, to animate it, to give artificial intelligence to the characters. It's a lot of work. Okay? So we're breaking it down here. So these are some of the things. There's game design. There's concept art. You guys know what concept art is? So basically, if I have an idea for something, but I'm not good at drawing things, I might hire an artist who can imagine and visualize things. And I'll tell them, hey, I need a soldier who can do this or do that. This is what they'll be doing in the game. So the concept artist will go ahead and create all kinds of variations of paper or computer. Show me, is this what you're looking for? Right? We will look at all that. So that's concept art. And once concept art is made, you have actual 3D models or artists making the actual model. That is where you have art. Right? And then once these models are made, somebody needs to animate them. Right? That's animation. You have audio in games. Do you know what UI is? UI? You know it. These guys. UI is user interface, right? Those are the buttons and the sliders and the color palettes and all of those things. Now in a game, those things are really, really important because if you have bad UI, it becomes really difficult to play the game. If you have bad UI, you break immersion. So it's really, really important to be very smart about these things, right? Then finally, you have programming. Programming is what brings all of these things together. Okay? So at Mogo, we teach some of these things. At Mogo, we teach concept art, we teach art, we teach animation, and we teach programming. Right? Some of these other things will come soon. But right now, we teach concept art, animation, and programming. Programming being one of the core aspects of game development. Okay? So let's look at some of these things in slightly more detail. So game design, I just spoke about. You have chess. Chess has very simple rules. Right? You have 16 on one side, all of them have different moves and powers. Now, based on those rules, you got to play the game. The gameplay. There are like millions of possibilities of gameplay, just from a few bunch of rules. Right? These set of rules is what game design is about. Like in any game you make, Clash of Clans, Fortnite, anything, somebody's got to make a set of rules. These rules make or break the game. Okay? And it is not easy. You can't just randomly make any game. Do you know what the number one tool is to make for game designers? I mean, to make art and stuff, right? There's 3D Studio Max, there's Maya, there's all of those things. If you want to program, there's C++ and all those things. But you guys know what is the number one tool for game design? Take a guess. Okay, Unity is a game engine to make games, right? You can make games, you can do animations, you can do all of that, right? But to design the game, any other guesses? To balance a game, to design a game, they use Microsoft Excel. You guys, Excel, yeah. I'm not kidding. Excel is where you actually balance a game. Okay? You don't program the game, you balance the game. Game design is done a lot in Excel. In MS Excel. Like if I give this character 100 points and this guy has 100 health or this much damage, how will it all balance out? All of that balancing, designers do use Excel. Once they like the balance, then somebody will go and program it. Right? Programming does not happen in Excel, only the balancing, only design. If you take these big, huge games like Clash of Clans or Farmville, Zynga Farmville, does anybody know? Farmville? Yeah. Okay, all of these games, they use Excel extensively to balance things out. Okay? Now here we see chess. Here's another game. Do you guys know this game? Yeah? Clash of Clans, right? Now all of these games have so many rules, right? And if the rules are not, if like one set of rules are really powerful and the others are weak, the game is not fun. Right? Your hero and your villains, they need to be more or less balanced out. If your hero is really powerful than the villain, the game is not fun. If the villain is way more powerful than the hero, the game is not fun. So how do you balance it out? There's so many things. There are weapons and there are magic potions, there are tons of things. How do you balance all these things out? That's where they use tools like Excel. Right? This is Clash of Clans. This, anybody knows this game? This is StarCraft 2. Right? This is one of those premier games known for game design and all of those things. Have you guys played Overwatch? Overwatch? Same guys. Right? So that is game design. Right? Game design is a completely different field. Game design is not about art. It is not about drawing. It is not about modeling. It is not about programming. It's got nothing to do with art and stuff. It is more about psychology and balancing things. Right? It's a completely different skill set. And you don't need to be a programmer or artist to do that. So in most studios, you might have somebody who specializes in game design, and they might also do programming. But that does not mean all programmers are game designers. Game design is a completely different skill set. Okay? Anybody any questions so far? No? Okay. So concept art. So once somebody comes up with a game design and they say this is the kind of game we want, the game is set in space and you have these ranges and they should look like this, they will come with all these weird ideas. Do you guys know George Lucas? Star Wars? Star Wars? Yeah, so he comes up with these ideas for Star Wars. Right? He'll say it is on a different planet, there are all these people who live there, but he doesn't know how they look like. He will just still a bunch of artists. This is what it is. So these artists will sit and they will come up with these drawings, how these characters should look like. Tons and tons of drawings. And then at the end of the day, George Lucas will just walk in, he will look at all these drawings, whichever ones he likes, he will pick those. And then they make them characters. So these are concept art, right? Based on the game or whatever. These are concept art made by artists for various different games, right? These are fully drawn and rendered, and then depending on the vision of the game and what the art director wants, he or she will choose the art that we need to follow the game. There are more examples. Again, Fortnite. These are all concept art for Fortnite, right? So tons and tons of concept art will be created for any game, but not all of them will make it into the game. Okay? And you can't just go about doing anything. There's usually a visual style set by the art director. Yeah? This game, Halo. Now here, earlier what we saw as concept art for characters, now this is concept art for the environment. Right? So this is a science, sci-fi game, set on a different planet. How should the game and the floors, everything look like? And what is the scale of things? You know, this guy's here, that little human thing, that is to show scale. That door or wood is that big compared to a human. To convey all of those pieces of things. And these will have a lot of detail and explanation as to why it looks like that. It is not just any random drawing. Why does the panel look like that? Why does it have an arch? Why is it all angular? All of those things are well thought out. Got it? Again, for Doom is another game. The main hero has a helmet. How should the helmet look like? These are all different variations made by the artist of the helmet, right? Again, Doom. How should the monsters look like? You can see that these concept arts are not very detailed. So this is how it starts. They will have a loose representation of an enemy or a monster or whatever. And then depending on whether the art director likes it, they take it further. Again, environment, concept art. You will see multiple variations. Right? You have the same environment, but see that? Another environment, the same angle, but different combinations. So the concept artist will make many variations of a scene so that the art director can choose whatever he or she likes. If you look at the same scene, look at it, and you will see it's a variation again. Right? Another scene, if you notice the rocks and the cliff and everything, they try to maintain but many different combinations. You can see how it changed. Right? But these are all made by concept artists. And this requires another set of skill you need to have. You need to know how to draw anatomy, perspective, colors, all of these things you should know if you want to be a concept artist. And these things are done either on a computer or on paper. These days everything's on computer. Yeah? So that is concept art. Any questions? By the way, we teach this in Mogo. If you're interested in being a concept artist, Mogo Media Academy is the place. Right? Once the concept artist makes all of that art, then it's time to actually model, draw, and create the art for the game. Yeah? So we're gonna, what are the different kinds of art? You have, if it's a 2D game, you have sprite sheets, just simple sprites. If it's a 3D game, you have 3D models, right? This is the sprite sheet. Now this is a 2D game. Now what can happen here is each of those character models could either be drawn by an artist or rendered out. But here there are no 3D models. It's just a flat set of images, like a flipbook. Have you guys seen those flipbooks? Where you can just draw something in this animated and slow animation. This is similar to that. You have a whole bunch of movements and you can cycle through them. And this is a 3D model. Right? 3D models, I'm sure everyone's seen because most of our games are in 3D. Here you can see fully normal, playing motion, and finally for the texture. You guys recognize the game? Overwatch, it's okay. Again, another model. Notice the tesselation on the face. All these models are made of triangles. You can see on the face there are a lot more triangles than the rest of the body. And there's a reason for all of that. That's for animation. The more triangles you have, the better animating it is. And there you have another character. Here's another character. Now here, you can see the model. And over there, it's textured and painted and rendered, all of that for the game. And that's how the finally look like in the game. But before that happens, somebody has to model. And you'll see numbers like this. These numbers are very important. This is telling you that the number of polygons in the model is 11,290. What that means is you want to make detailed characters, but anybody can make a character. But if you want it to run in a game, it has to be performing. What that means is the models have to be very optimized. So the idea is make a model as detailed as possible, but very few triangles. That is the skill, right? How good a character can you make with 10,000 triangles? That will take a lot of skill. But if I said, hey, take 1 million triangles, go do whatever you want, you might create the most realistic model, but it will not run in the game. Because all these triangles will need to be computed and lit and rendered. So more detail you have, the slower things become. So computer game development is essentially about optimizing things so that you can run a lot of characters and a lot of assets in real time. Yeah? So the skill here is to have detailed models, but lower triangles. That is why we specifically mentioned the polygon. Because every game has a budget. Beyond that budget, you should not go when you make your assets. If you do, they will they'll throw the asset out. Here's another asset. Again, this is a monster for a game, no way out. You can see the model here. It has 11,135 polygons, and there it is all lit, textured. And in the next slide, you should see it animated in the game. This is how it looks like. Finally. Yeah? Any questions? No questions? Okay. Yeah, so we have covered concept art. We have covered what? Game design. Yeah. Now let's talk about animation. Now, all of these things that I'm talking about, I'm going through really fast, right? Because in each of these things, there's a ton of things to talk about. Right? Now, animation. Animation is not just about characters. There's a whole bunch of things that go into animations. And there are different kinds of animations. There's both 2D and 3D. But even between 2D and 3D, you have character animation, right? The characters in the games, right? You also have props that need to animate. You might also have environments that need to animate. And if you know UI, user interface, in most games the UIs are very complex. So even the UI has animation. And all of these things require a solid understanding of colors, movement, human psychology, and animation. Yeah? So here, this is 3D animation or 2D? Yeah, 2D animation. This is 2D animation, right? Now, what is amazing about that is you have that character jumping and doing all those things. Because each frame is hand-drawn by the artist. Right? Each frame of that jump and punch and kick is hand-drawn. Okay? It requires tremendous skill to do things like that. Yeah? We teach that at Mogo. Right? So that's a 2D animation. Shall I move to the next one? Or do you guys want to keep looking at that for a little longer? No? Okay. Here's another one. Do you guys know this game? No? Never seen this? Prince of Persia, yeah. It's really, really old. They don't think you guys were born at that time, except maybe you. You and I were wrong. But the rest, this is like a really, really old game. Now, back then when the guy made this game was a huge hit, Prince of Persia. This is like early 1980s. Yeah, really, really, really long. So the way he made this animation back then was he video recorded his brother to do all these movements. And then he took the footage and then he put a piece of paper on top, he would pause the video and he would trace it. That is how we drew out each frame. The Prince of Persia, the character in the white dress, that is the prince. That is essentially his brother, the game programmer's brother. Got it? So this is a 3D or 2D? 3D or 2D, guys? 2D. That's 2D animation, right? Okay, so that's character animation over there. What do you think this is? This is made in Unity, by the way. Unity? This is Unity. And these are known as particle effects, right? If you want to have explosions and smoke and steam and fire, water, you need to know how to animate particles, right? So this is an example of that, right? This is done in Unity. Again, we teach this at Mogo Media Academy, right? Any questions? Now, this is an example of UI animation. This is from a very popular game. What I want you to do, yeah, you see that? The hand is a meter, and you see all those radar things. And in a moment, you will see all that. See all of that? See all of this is happening in the UI? That's right. This is all UI animation. And this is not easy. It's quite complex to make UI animation. Right? And it's a very critical part of game development. If you have bad UI, everything will slow down and your game will not be responsive or fun. Right? But if you have really good UI, your game can become very immersive. This is alien isolation. Can you guys play this? Like alien isolation. Yeah. You look like?
Yeah.
Really? Yeah. It looks very real. And this game is 11 years old. 11 years ago this game came out. Right? And it is based on the movie Alien. Right? This game is known for some really amazing AI, artificial intelligence. It's a really gorgeous little graphics. Right? See all of this UI, all of this map showing all of the really things, the way the text is laid out, even this statue in the bottom, all of that is thought through. It is not some random appearance. Right? And in order to make UI like this, there's a lot of science that goes behind it. Right? So this is UI animation. Should I move on? Do you guys want to? What's the anything else? Yeah. Now, here's another game. Again, you will see a whole bunch of animations here. You will see all the trains and particle effects, but you will also see the UI. You see this? This is all UI animation. UI animation is very critical to make it fun. It is not just the UI, it is also all the particle effects that you see. All the arrows, all the shaking movements, all of this. All of that is very critical to animation. Now this is another one. This is what I'm going to do. You guys know this game? Okay, this is a PC, sorry, this is a mobile phone game called Mogo Media Academy. A brilliant game. Now here, there's no character animation. This is not no character animation. All of there's character in it. Can you guys hear me? Loud and clear. My throat is. But anyways, this is about object animation. Right? You will notice the entire product, but you will also see each individual things rotating and animating. And it is all really critical to the game. And notice how the characters are always perpendicular to the surface, even if it's upside down. The white character. So all of this is part of what? Is it part of audio? Is it part of concept? Animation. It's part of animation. More than that 3D animation. We saw 2D animation, we saw object animation, we saw UI animation. This is the amount of detail you have, 3D characters, these things. See all that? You can control all of that. All this. This is running in Unreal.
What's happening?
That's called, what is that called? Motion capture, right? Where the humans actually act out the animation, right? And their performance is captured by all the little dots on it, right? And that animation is transferred to a digital model. And that's what you see in the game, right? To do this, you need a motion capture setup. At Mogo, we have a motion capture studio, right? And you can capture motion animation, right? So this is for the game called Gears of War. And the actors are playing out the animation of falling and getting shot and all those things. And that animation gets transferred to 3D. So they're acting out all of these things. They're acting out all of it, and then you can see in 3D. That is transferred, the animation. This simplifies the work of an animator. Right? You can see the same animation now inside the game. Initially acted out. Okay. And this is acting out these things. And this is all running on Unreal Engine. You guys know Unreal Engine? Yeah? This is Unreal. Yeah. Those are all, that thing you see on the right is a rig to control the facial animation. Yeah? Any questions? Nobody? No questions? So what all have we covered so far? We spoke about concept art, game design, animation element, yeah. What's next? AI. We keep hearing AI all the time. Right? We do, right? ChatGPT, our new friend. And what is AI? AI is ChatGPT. That is not correct, right? AI, in this whole ChatGPT, LLM thing, we've heard of it for the last 5 years, but in games, AI has been active for 20, 30 years, right? Games have been using artificial intelligence for a very long time, right? Especially in the beginning, AI was used in games for pathfinding. You guys know pathfinding? Like in games, you might be standing somewhere, and the enemy is somewhere else, and the enemy needs to get to you. How does it know how to get to you? There might be a brick wall, there might be obstacles in between, but it needs to go around and find a way and come to you. That process is called pathfinding, and for that you use AI, right? And that is some of the very early versions of games had a lot of pathfinding algorithms, right? These are actual coded algorithms, right? Computer science is used heavily in game development. In fact, game development is one of those fields where you have many streams of computer science coming in. Like for instance, if you want to make a game and use a game engine or all of those things, you will need to know rendering, that's computer graphics. If you're doing multiplayer, you will need to know how networks work. You will need to be able to program networks. You will need to be able to perform all kinds of network IP netting things. You will need to know AI if you want to make games, like actual algorithms. Like if you want to do audio, you need to understand how audio works. A lot of these things come into game engine development. It's one of those few areas of computer science where multiple domains come into play. Yeah. So AI over here mentions pathfinding. Pathfinding is some of the very old techniques of how to get from one point to another. And then games evolve to something called finite state machines. So we have games like Halo and Half-Life and all these things. They're very complex interactions, right? They can come and attack you in teams. They can switch weapons depending on how vulnerable you are and choose the right weapons to attack you. All of these decisions they can make on the fly. And for that you have something called a behavior tree or a finite state machine, right? So these are all the kinds of AI techniques that we use in games, right? But ChatGPT and such things, they are not about pathfinding. They're about, what is ChatGPT all about? They use something called LLMs. LLMs stand for large language models. Yeah. So which is a completely different domain of artificial intelligence. And that is not what we using games. All those these days, maybe you can write a chatbot inside the game using LLM techniques, which means you might have a character in the game that can talk to you, that can have a conversation with you, like how ChatGPT does. Right? So you can integrate these things. Right? But AI in games is much more than all that. That is this, like, I'll show you a pathfinding video. Now, what you're about to see in the video is you will see a red dot and you will see a green dot. And the computer is trying to find the path from the red to the green. Right? And this is what you're going to see. You're seeing it evaluating. Let me play it again. It's running too fast, but you can see the computer is trying to find the path from here, from this dot to that green. It is evaluating the options, and this is a slowed down version. It is looking at all the surrounding nodes to see, can I get to that spot? Once it gets to that spot, yeah, it's found the path. One of the most optimal paths from this dot to that green dot. Right? This is a pathfinding algorithm, and you will see this extensively in a lot of games. Yeah? You guys like that? It's called A-star. The algorithm is called A-star pathfinding algorithm. And these algorithms are very old, right? Much, much older than your LLMs. Do you guys want to keep looking at it for another second? Or shall I switch? Switch? Okay, so unfortunately, finite state machines, I can't show it to you because of a bunch of code. But what you see in effect are these smart games where the enemies actually tactically plan to attack you. So almost all games these days use FSM in some form. Yeah? And all of this is part of computer game development. Any questions? Nothing at all.
It's like a project management.
Project management. No. So what is happening here is it is associating a cost for every node in a terrain. And then it's trying to understand, if I need to get there, what is the cost of going to this path or that path? And then it finds the cheapest cost path. It's called A-star. Right? Okay, shall I move on? Any other questions? Again, computer science, game development is very integrated with computer science. It is not all about computer game development is very, very different from playing a computer game. You understand that, right? Playing computer games is about shooting and killing and winning and losing and all of that. Computer game development is actual computer science. Okay? And I think there's a lot of programming is where all of these things come together. You guys know? It's quite long. That's where they give us. Yeah. So, when it comes to programming, and I think this is the last one, do you guys know what programming languages are used to make games? C#, yes. Anything else? Java? Okay, anything else? Python, yes. Anything else? C++? Yeah, C++, yes. Have you guys heard of Unreal or Unity? Unreal, Unity, have you heard of? No? So there are these game engines, right? So game engines help you make games. You don't have to write renderers and networking code and all of those other things. Because if you were to do all of that, you will take years to make a game. So these days you have things like Unity or Unreal, which handle all of that, right? And then you can write your game using that, right? At Mogo, so yeah, so
guys know psychometric tests? He's talking about a psychometric test. Have you guys done any of that? You did? Yeah. If you haven't, you can get it done. Okay, so at Mogo, we teach both Unity and Unreal to make games. So what are these things? These are very complex pieces of code that allow you to make games easily. Not just games, any interactive simulations or software you can make using Unreal or Unity, right? Like for instance, and Unreal uses C++. Unity uses C#. But that doesn't mean that these two are the only languages that you can use to make games. You can make games in any language. The concepts are the same, right? So we teach at Mogo, we don't expect you to have any programming background. We start from the beginning. We teach you how to program a computer, how to program it correctly, right? Using C#, right? Once you learn all of that, just programming, and that's about 2 months, you only learn programming. There is no graphics, there is no games. It is just programming and algorithms. Once you are familiar with programming, then we start making games using Unity, and then we move on to Unreal, 2D and 3D games, right? And that's a 1-year course at Mogo. We do that. And here I have a small video of how we can do something in Unreal using something called blueprints, where you can visually create code without even having to write C++. Any questions? If you guys have any questions, feel free to ask, right? Don't feel shy. Just ask, right? I can clear all your doubts. So, this is Unreal, the game engine, and Unity, the game engine. And here is a video. This is Unreal, by the way, and this is an example of how you can use something called blueprints to have a door that is interactive in a game. So it's not very clear here, but the overall idea is that just by clicking a bunch of things and forming logic, you can have an asset like a door that is interactive in a game. Of course, you can do much, much more complex things. Have you guys seen Fortnite? Fortnite, the game. Fortnite is made using Unreal. Or Overwatch, or... Yeah, maybe... Yeah, he's dragging an asset of a door, and then he's going to write the code to make the door interactive. It's a short video. It'll finish soon. Maybe. Yeah, so that's the door frame. He's signing that, and then he's going to add behavior through code to make it interactive. That is the door frame, right? What we want is that we want to have a door open and close in a game based on proximity. When you stand close to it, it should open. That is the behavior we want, and this video is showing you how we can do something like that quickly. Okay, maybe not so quickly. You see the sliding door? You see a door over there? He's putting it all together, and this is not done by an artist. A programmer can do this. All the assets are already there. You just need to place it in. This is Unreal Engine, and very easily through code you can make it slide and open and pivot and all of that. I might just... Yeah, so that is how you write code in Unreal Engine. This is one way. If you're not very keen on writing C++ code, you can use something called blueprints, which is essentially C++ code. By dragging and dropping, you can write programs, and it's really, really powerful. And it makes it very, very easy for people who are new to programming to use Unreal. You can create logic and make games. He's doing a lot of talking. Yeah, so you can see they're finally placing the dough. They're finally placing the dough in the environment. And the whole idea is that the character, when you move the character and come and stand close to the door should open automatically. Now that behavior is already programmed, and you will see, yeah, the door is opening. And then it closes after a while. And as long as the person stands there, it does that automatically because the code is written through blueprints. And this is Unreal Engine. So you can do very complex things with Unreal. Yeah, that is that, Unreal Game Engine. Any questions? Anybody? Nobody? Nothing? Okay, so that's it. So at Mogo, we teach programming, we teach concept art, and we teach animation, right? We do plan to start in the next year or so with creating 3D models and textures and all of that. But right now, we teach animation and programming. And both courses are a year long. And with the programming course, we teach from the basics. You don't need to have any programming background. As long as you're passionate and interested, we'll teach you. Right? So that's a Mogo Media Academy. If you have any questions, you may ask. Else, we're done. Right? Anybody? Anybody? Yeah.
The platforms that you are talking about, those are SaaS product, or is it a software that we need to install in our local machines?
SaaS is a sassy word. Right. So the software, his question basically is, we saw Unreal and Unity, right? Are those things that we can install, or do we have to pay a lot of money and buy? These engines are free. Unreal and Unity are highly powerful pieces of software used by everybody in the industry, and they're fully free, right? You can download them today if you go to unrealengine.com or Unity, and you can download the whole engine and you can start making games. And you can publish the game. You don't need to pay them, right? If you hit $1 million USD, if you make $1 million US from that game using Unreal or Unity, if you do, then from that point on, you just need to pay them a small royalty, but only after you cross $1 million USD. The first $1 million USD is all yours. You don't have to pay them, right? And this is used not just by game developers, it is used by scientists for simulations, for real-time computer simulations. It is used by architects for pilots, for flight simulators and things like that, right? To train pilots, you can have flight simulators made in these things. It is used for architecture visualization. It is used for so many things. For medical visualizations, medical training, for VR, for mobile phones, for games, for applications. And it's all the same. The base underlying thing is the same. You can use blueprints or C# or any of those things and program whatever you like. Yeah? And that's got nothing to do with Mogo. Those software is made by companies in the US, right? And they're very old and they're very, very powerful. We just teach you how to use them.
Between those two, what do you prefer?
My personal preference is Unreal. Yeah. Any reason? Because Unreal is about 20 years old, right? And they're technically far superior to Unity. I'm not saying Unity is bad. They're technically far superior to Unity and far more powerful, but also incredibly complex to use. Unity is much more easier to get into and start doing things, but Unity is also very powerful. But Unity is relatively much younger. Unity is about 15 years old, right? Less than that maybe. But Unreal since 1994, right? Right, and before game engines became very commercially available, if you wanted to use Unreal, you would have to pay them millions of dollars so that you could use them. But even if you had millions of dollars, they would not give it to you. You would have to prove to them that you are capable of making a good software, a game or whatever. Only then will they give it to you. But then Unity came many, many years ago, many, many years later, because of mobile phones and stuff. Unity became very popular. And Unity was free. And then after a while, Unreal decided to become free as well, to compete with them. But yeah, my personal preference is Unreal. Yeah.
Could Millinode be used? Millinode?
What?
Millinode. We, we put all the ideas in that.
I'm sorry, I don't know. I don't know Millinor, right? But I can look it up for you. Millinor, I'll look it up for you. Yeah, but I don't know what that is. I'm new here, so I don't know what Millinor is. Yeah, yeah. Any other questions? Yeah.
Other than now as a trend is gamification. Yeah, other than the games, if I in our business, if you apply the gamification, what are the things need to consider if you apply the gamification?
So his question is, gamification is a thing. In order to gamify something, what are the various things we should consider, right? Now, gamification is not game development, right? It is more like game design. How do you make something really interesting and exciting to use? Let's say you have a banking app, which is like the #1 banker in Sri Lanka. Is it HNB or Commercial Bank or Sampat Bank? Let's say it is HNB, right? Let's say it's HNB. Let's say they make an app, right? But the app is ridiculously complex to use. Then it's not fun. It has to be fun to use, right? Like even from little things like the UI animation, and even not just useless things like UI animation. It has to even have value, right? So for all of these things, they use concepts of game design. It's called gamification. It can be applied anywhere, not just in games. It can be applied to even websites or digital apps or any experience related to a user. It's called UX, user experience magnification, right? So basically game design, that's the thing you would need to consider, right? To how to make something really exciting and interesting to use. Anything else? Ma'am, yeah.
So, have you tried playing Clash of Clans? Okay, so I've been playing Clash of Clans for a while now, almost like 15 years. So there'll be so when attacking in war, you have to go war, and when attacking in war, I'll almost destroy most of the buildings, and there'll be one left. The queen will have an easy path to go near it, but she'll go around and I'll lose it. So why does it happen? It's happening for a while, and Clash of Clans didn't fix it at all. Like, what do you think? Why is it happening? Like, she has to go for a round and come rather than just going inside. Yeah.
I can only speculate because I've not played Clash of Clans, and I don't know if that is an intentional decision, right? Because there are algorithms, like we just saw a few things, where you can actually get to any point directly in the shortest path. But these algorithms are not easy to implement. You really need to be good at computer science and computer programming to implement these things, right? Maybe they don't have good programmers to implement it. I don't know. Maybe that is an intentional design decision where the queen should go that way, right? I don't know what it is, but it could be any of these things. Yeah. Yes, sir.
What do you think about Godot model engine?
Okay. So my good friend here is asking me, what do I think about Godot? Godot is another game engine, right? Apart from Unreal and Unity, there are other game engines as well, right? And Godot is one such, right? They're quite powerful. It really is not about the engine. It is not about the hammer. It is how you wield it, right? So you could use Godot, but if you know what you're doing, you can make amazing things with it, right? But the only other issue with Godot is that it is an engine that is, still being developed. The user interface and UX might not be as good as Unity, but that does not mean it is not powerful. It is actually quite powerful. But things like Unity and Unreal, the tons and tons of developers sitting and working on it every day, right? So they release features and bug fixes much, much faster than Godot. Yeah, but you can use any of these things to make whatever you like, right? Godot is very powerful. Any questions? No? Anybody? Yeah.
for game development, is there a specific desktop platform that should be used? Is it should be a Windows, or is it good to be have a Macintosh?
Yeah. So the question is, for game development, what is an appropriate platform? Should we be using Linux, Mac, or Windows? Well, if you have Mac, if you have a Mac, it's fine, but Windows is the best, because the amount of options you have in terms of tools and all kinds of things is much, much higher on Windows, much higher, right? And then you have Mac, and then a far, far thing you have Linux. Yeah, but Windows is number one when it comes to game development software. Anybody else? Anything? Any other loose, free, unanswered questions? Anything else? Anybody? No? Yeah, one more.
Can I get to know the basic structure or the outline of the game development course that you are going to be having in the Mogo development?
Can we have a basic outline of the game development course is the question. I don't have it with me, but I can tell you. So it's a 1-year course. It's broken into 2 semesters. The first semester is all about Unity. The second semester is Unreal. And in the first semester, in both these semesters, first semester, second semester, there are 3 modules each, right? So in the first module, when a student comes in, we do not expose them to game development. It is purely C# programming. How to program a computer, all the different constructs, how to use logic to create things. You have to get really, really comfortable with that. And that's a 2-month program. Once that is done, the first module is over. Then you get into Unity, and you use C# to make Unity 2D games, right? After that, you get into Unity 3D. The first semester is over. Then we start with Unreal. Again, with Unreal, when we start programming, there's something called blueprints. But because by that time you're already familiar with computing logic, blueprints is really easy to learn. You'll pick that up really fast. Then we get into Unreal 2D and then Unreal 3D. In the whole process, we make about 8 or 9 small games. And each of these games is not about visuals. It's about learning to program certain concepts and how to do these things really smartly. That is the goal. And then in the in the end, there's a student project where students get to make things. Oh, I forgot to show you. There's a reel that I have, a reel of some of the games that our first semester students have made. They're still studying there, but at the end of the first semester, they made this. Do you guys want to see? Yeah? Okay, let me find it. I almost forgot about it. This is made entirely by our students. Okay.
since you gave a real motivational guidance, so I need to add to that. Please Google search salary scale of Unreal Engine developer. If you Google search, it will show a very interesting amount. So these guys will maybe be interested for looking at all the opportunities they have.
Basically, what he's saying is that if you are an Unreal Engine game developer, you can make a lot of money. Yeah, that's what he's saying, right? So the thing is, the opportunity is not just in Sri Lanka, right? There are tons of studios all around the world, and they need Unreal and Unity developers, provided you're really good at it. So if you should not be thinking about, I just want to get into a company in Colombo or Sri Lanka. The whole world is your opportunity if you're really good at it. Yeah, so if you do well, tons of opportunities, right? And especially in Sri Lanka, there isn't much of a gaming industry right now, but it's slowly blooming. So it is a very nice time to get in because you can really leave a mark if you're really good. And plus, there are tons of opportunities abroad. Yeah? Any other questions? No? So thank you then. I will see you guys probably at Mogo. Right? Alrighty. Have a nice day. Bye-bye. Thank you.